Hi, this is Mrs. Rodriguez, your Algebra 2 teacher. This video is a review for the Chapter 7 test that's coming up. What I suggest you do is when a problem comes up on the board, pause the video, try to solve it yourself. And if you can, you get the correct answer, great, move on to the next problem. If you can't, if you get the answer wrong, try to figure out what your mistake was based on my explanation. And then if you still can't figure it out, please see me in my office hours or please email me. If you take a screenshot of your work, maybe I can figure out what your mistake was. Remember, I'm here to help. So please reach out if you're having difficulty with any of these problems, okay? So this is a review for the Chapter 7 test that's coming up. There are selected problems from a practice test that's on page 521 of your textbook, okay? So the first section talks about, or the first couple sections talk about exponential functions in the form of y equals a times b to the power of x, where a is not equal to 0 and b is greater than 0, okay? And then b is not equal to 1. So the property of equality for exponential functions, if b is a positive number other than 1, then b to the power of x is equal to b to the power of y if and only if x is equal to y. So in other words, if we can get the bases to be the same, then their exponents are going to be equal to each other, okay? And then the property of inequality for exponential functions, if b is greater than 1, then b to the power of x is greater than b to the power of y if and only if x is greater than y, and b to the power of x is less than b to the power of y if and only if x is less than y. So in other words, again, if we can get the bases to be the same, even with inequalities, then their exponents are going to be equal to each other, okay? If we have variables and exponents, then we can solve for that variable, okay? All right, so first thing you need to know how to do is how to graph a function, okay? And then it also says here to state the domain and the range, okay? Remember, the domain are the x values, and then the range are the y values, or the y values, or f of x values is another way to say it, okay? So here we have f of x is equal to 2, and then in parentheses 3/4 to the power of x plus 1 minus 3. Okay, so just like any time when we're graphing, you're going to pick some values for x, and I'm going to pick -3, -1, 0, 1, and +3. Oh, excuse me. So I would put 2 and then 3/4 to the power of -3 plus 1, all of that minus 3. So this becomes 2 times 3/4 to the power of -2 minus 3. And then type that in calculator, 3/4 to the power of -2 times 2 minus 3 ends up being 5/10, and it keeps repeating, okay? Then when you plug in -1 in for x, you get 2 times 3/4 to the power of 0 minus 3. Remember, anything to the power of 0 is equal to 1, okay? So this ends up being 2 times 1 minus 3. So 2 times 1 is 2 minus 3 is going to be -1. When you plug in 0 for x, 2 times 3/4 to the power of 0 plus 1 minus 3. So the exponent for 3/4 is now going to be a +1. And then 3/4 to the power of 1 is 3/4 times 2 minus 3 ends up being -1.5. And when you plug in a +1 in for x, your exponent is 1 plus 1. That ends up being 2 to the power of 3/4 squared minus 3, which ends up being -1.875. And then finally, when you plug in 3 as your x value, 3 plus 1 minus 3, you end up getting 2 to the power of 3/4. I'm sorry, 2 times 3/4 to the power of -2. I'm sorry, this ends up being +4, the exponent. +4 minus 3 is equal to -2 and 36/100. Okay, so when you graph this, okay, you've got -3, +5/10. Okay, so over at when x is -3, at +5/10, you have a point there. And then when x is -1, y is -1. So -1, -1. And then when x is 0, y is -1.5. So that's here. And then when x is 1, +1, it's going to be a little bit lower, -875,000. And then when x is 3, again, it's going to be a little bit lower again. Or it's actually going to be -2 and 36/100. Okay, so about there. So what you end up having is a graph that looks like this. Okay, so when we're talking about our domain, remember domain are the x values. So x values, it's going to keep on going to the right and it's going to keep on going to the left. So it's going to be whole real numbers. And then the range are all of your f of x or y values. Okay, so if we notice our y values is going to keep going up, they're going to keep increasing, but there is an asymptote over here at -3. Okay, it's not going to cross -3. Okay, so our range is f of x. F of x has to be greater than -3. Okay, so there's our domain, our range, and then there's our graph as well. Okay. All right. So next section talks about logarithms and logarithmic functions. So suppose b is greater than 0 and b is not equal to 1. For x is greater than 0, there is a number y such that log base b of x is equal to y if and only if b to the power of y is equal to x. So this is going to be really important. This is your logarithmic function, okay? So it might ask you to write something in logarithmic function, and then this is your exponential function. So you're going to be going back and forth from these two, okay? These two different forms. And then the logarithm of a product is the sum of the logarithm of its vectors. The logarithm of a quotient is different, okay, of the logarithms of the numerator and the denominator. The logarithm of a power is the product of the logarithm and the exponent. And then the change of base formula. Here we have log base a of n is equal to log base b of n over log base b of a. Okay. All right, so if we have something like this and it says to solve each equation or inequality, round to the nearest 10,000th if necessary. Okay, so here we have our exponent in our, we have our variable in our exponent. So we want to get the bases to be the same so that then we can set our exponents equal to each other. Okay, well, 8 has factor of 2, and 2 times 2 times 2 is 8. So 2 to the third power is 8, and this is still raised to the power of c plus 1. And then 16, 2 times 2 times 2 times 2, so 2 to the 4th power is equal to 16. And then still raised to the power of 2c plus 3. Now we're raising a power to a power, so we're going to multiply these exponents, okay? So we're basically applying the distributive property here. So this is going to become 2 to the power of 3c plus 3. And over here, same thing, we're going to apply the distributive property. It's going to be 2 to the power of 8c plus 12. Now our bases are the same, so we can set their exponents equal to each other, okay? And then now we just have an equation. We solve it like we've been solving equations all year long. So this would be 3 equals 8c minus 3c is going to be 5c plus 12. And then I'm going to subtract 12 from both sides. I end up with negative 9 equals 5c. And then I would divide both sides by 5. So negative 9/5 is equal to c. And that's as far as we can go. Notice I left it as a fraction. Several students on their quiz were changing these to decimals. Just leave them as fractions, okay? All right, problem number 4 says, here we have 9 to the power of x minus 2, and then 1 over 27 to the power of x. So again, we have to get our bases to be the same. So 9 is equal to 3 squared, right? 3 times 3 is 9. And we're still raising that to the power of x minus 2. 1 over 27, well, we can put 27 is equal to 3 cubed, because 3 times 3 is 9, times 3 again is 27. We're still raising that to the power of x. So then I would apply the distributive property here. Then when I'm raising a power to a power, I multiply the exponent. So that becomes 3 to the power of 2x minus 4. And when I have a fraction here, remember that is a negative exponent. So that's 3 to the power of negative 3. And it's still being raised to the power of x. So then this becomes 3 to the power of 2x minus 4 is greater than 3 to the power of negative 3x. So again, I would distribute here or multiply the exponents. Now my bases are the same, and I can set my exponents equal to each other. So I'll just do that over here. 2x minus 4 is greater than negative 3x. So then I would add 3x to both sides. I get 5x minus 4 is greater than 0. Then I would add 4 to both sides. Remember, I'm trying to isolate x. So then I have 4 over here. And then I would divide both sides by 5. So x can be greater than 4/5. And then that is my final answer, okay? Oh, I can also write my answer like this. Okay. All right. Next problem here, number 5. Here our bases are not the same, okay? So we're going to use the property of equality for logarithmic functions. So we can say that log of 2 to the power of a plus 3 is equal to log 3 to the power of 2a minus 1. And then we're going to apply the power property of logarithms. Okay, so this power here, put that in front of our log of 2 is equal to 2a minus 1 times log of 3. And then we're going to apply the distributive property. So a times log 2, so that'd be a log 2 plus 3 log 2 is equal to 2a log 3 minus log 3, okay? So then what we can do okay, so now at this point, we have our variable on two different sides here. We've got a over here, and then 2a over here. So what we're going to do is subtract 2a log of 3 from both sides. So this is going to be a log of 2 minus 2a log 3, and we still have that plus 3 log of 2 is equal to negative log 3, okay? And then we can get rid of this or move this over, this 3 log of 2. We're going to subtract 3 log of 2 over here as well. So then what we're left with is a log 2 minus 2a log 3 is equal to negative 3 log 2 minus log 3. Okay, now let me see if I can, I'm going to rewrite that up here. A log 2 minus 2a log 3 equals negative 3 log 2 minus log 3. Okay, so now we have to isolate, or we can factor out this a, because we've got a, both these terms. So we're going to take out a, and we're left with log 2 minus 2 log of 3 equals negative 3 log 2 minus log 3. And then we have to isolate a, right? So a is being multiplied by this, so we're going to divide both sides by log 2 minus 2 log of 3. Log 2 minus 2 log of 3. And then over here, we're going to be left with a. And then, so a is going to be negative 3 times log 2 minus 1 log 3 over log of 2 minus 2 log of 3. Okay? All right. So when you type all that in your calculator, okay, you definitely want to use a calculator for this, a scientific calculator. If you're using your cell phone as a calculator, it's going to say error when you try to do this. So you need to use a scientific calculator. If you don't have one, you can just Google free scientific calculator, and Desmos is the one that will work for you. Okay, when you do that, a is equal to 2, and then you have 11295, but it says to round to the nearest 10,000 if necessary. So that would be the 9th place. Okay, so, and over to the right is a 5, so we're going to round that up. So a is equal to 2, 1, and 1,130 10,000. Okay? All right, so next problem, number 6, says to solve each equation or inequality, round to the nearest 10,000 if necessary. Okay, now here we have log base 2 and also log base 2 here. Okay, so we can set this x squared minus 7 equal to 6x. Okay. All right, so now I'm going to subtract 6x from both sides. So I have x squared minus 6x minus 7, okay, is equal to 0. And then I can factor this. The factors of -7 that add up to -6 are going to be +1 and -7. So we put x plus 1 equal to 0 and x minus 7 equal to 0. So x equals -1 and then x equals 7. So we can't have a negative solution. So the only solution is x is equal to 7. Okay. All right, now number 9. Again, we have our bases that are different. Okay. So we have to use the property of inequality, because now this is an inequality, for logarithmic functions. So we've got log of 6 to the power of n minus 1 is less than or equal to log of 11 to the power of n. So then our exponent here, we're going to apply the power property of logarithms. So we're going to multiply n minus 1 times log of 6 is less than n times log of 11. Then on this side, we're going to apply the distributive property. So we've got n times log 6 minus 1 times log of 6. And then we still have n log of 11 over here. Then what I'm going to do is I want my variables on the same side. So I'm going to subtract 2 log of 11 from both sides. So I have n log of 6 minus n log of 11. And I still have this minus 1 log of 6 is less than or equal to, then I have 0 over here. So then I'm going to add, because this term doesn't have a variable, I'm going to add 1 log of 6 to both sides. And then I end up getting n log 6 minus n log 11 is less than or equal to 1 log of 6. Okay, so then what we're going to do is factor out the n here. So we have n times the difference between log of 6 minus log of 11 is less than or equal to 1 log of 6. So now, again, we're trying to isolate n. So I'm going to divide both sides by log of 6 minus log of 11. So here, log 6 minus log 11. So then n is going to be less than or equal to 1 times log of 6 over log of 6 minus log of 11. So again, you need to be doing this in your calculator. And when you do that, you end up getting this big long decimal, -2 and 95603. So they want you to round to the nearest 10,000. So we have 3 and 100,000. So we're going to keep the digit in the 10,000s place the same. Okay. So that's going to be our final answer, -2 and 9,560 10,000s. Okay. All right, so now next section is going to talk about natural logarithms. So since the natural base function and the natural logarithmic functions are inverses, these can be used to undo each other. Okay. So the natural base function and the natural logarithmic functions are inverses. All right, so it says to again solve each equation or inequality, round to the nearest 10,000th if necessary. So here we have 4 times e to the power of 2x, and this is all minus 1 equals 5. So first thing, we want to get this minus 5 to the other side of our equation here. So now we've got 4 e to the power of 2x is equal to 6, okay? Then we're going to divide both sides by 4. So we've got e to the power of 2x is equal to, when you simplify this, ends up being 1.5. So now we're going to use the natural log. Remember, these are inverses of each other. The natural log of e to the power of 2x is equal to the natural log of 1.5. Then I'm going to set my exponent 2x equal to natural log of 1.5. And then I'm going to divide both sides by 2. So x is going to be equal to the natural log of 1.5 divided by 2. And when you type that in a calculator, you end up getting 0 and then 0.20273. And again, it says to round to the nearest 10,000. So we've got a 3 in the 100,000. So this would stay the same. So this ends up 0 and 227, 2027 10,000. Okay. All right. And then I'm going to go ahead and do the next one, number 11. So we've got e. So we've got natural log of x plus 2 raised to the second power is greater than 2. So we don't have to isolate anything. It's already been isolated. So we've got e to the power of natural log x plus 2 squared is greater than e squared. And then, so then we've got x plus 2 squared is greater than e squared. So we can take the square root of both sides and we get x plus 2 is greater than e. Then we would subtract 2 from both sides and x is greater than e minus 2. Put that in a calculator and it ends up being 71828. So we're going to round to the nearest 10,000. In the 100,000s, we have an 8. So we're going to round that up to 7,183. So x is going to be greater than 7,183 10,000s. Okay. All right. And then number 12, we have log base 5 of 44. And so it tells us here that log of 11 is approximately equal to this decimal here, and log base 5 of 2 is approximately equal to this decimal here. So we're going to use these values to approximate the value of this expression, okay? So log base 5 of 44, we can break that down to log base 5 of 2 squared, right? 2 times 2 is 4, times 11, okay? So we would take our exponent here, put in front of our log, base 5, oops, base, okay, sorry about that. Let me just rewrite it. So this exponent 2 is in front of log base 5 of 2 plus, because remember this is where you're applying the properties of powers. So if you're raising a power to a power, you're multiplying it. And if you're multiplying 2 powers, then you're going to add m. Okay, so we've got log base 5 of 11. Okay, so then we have 2 times log base 5 of 2. They told us to use 4,307 10,000ths, plus for log base 5 of 11, they said to use 1 and 4,899 10,000ths. So here we apply order of operations. We're going to multiply 2 times this first. So this is going to end up being 8,614 10,000ths plus 1 and 4,899 10,000ths. So it ends up being 2 and 3,513 10,000ths. Okay. So we just broke this number down into factors using the information that we're given. Okay. All right. So using exponential and logarithmic functions. Okay, so exponential growth can be modeled by the function f of x is equal to a times e to the power of k times t, and k is a constant representing the rate of continuous growth. And then there's exponential decay. Formula is very similar, except you're taking the negative constant and multiplying that by the time. Okay. So let's look at some of these. So number 18, you put $7,500 in a savings account, paying 3% interest compounded continuously. Assuming there are no deposits or withdrawals from the account, what is the balance after 5 years? Okay, so this is going to be exponential growth. So we're going to use this f of x is equal to a times e to the power of k times t. So we're looking for f of x or y. And then a is going to be the original amount. So that's 7,500 times e to the power of k. K is 3%, but remember we have to change that to a decimal. So that ends up being 3/100. And then times time, it's asking about 5 years, okay? So this ends up being y equals 7,500 e to the power of 1,500, okay? So you plug in e to the power of 1,500, you end up into your calculator, and you end up getting 1 and 1,618 10,000ths. And then when you multiply that by 7,500, you get $8,713.76 to round into the nearest hundredth, because we're talking about money here. Okay, so $8,713.76. Okay, so you're just plugging in the information that you're given into the equation. Okay. Right, next problem. This is an additional practice problem, so you will have one very similar to this on the test. It says, for a certain strain of bacteria, K is, and it gives you this 728 thousandths. It's already given to you as a decimal, when T is measured in days. Using the formula y equals a times e to the power of k times t, how long will it take 10 bacteria to increase to 675? All right, so we're starting with our equation, a times e to the power of k times t, and we're just going to fill in what we're given, okay? So it's asking us how long will it take 10 bacteria to increase to 675? So y we want is going to be 675. The original amount is 10, because we started with 10 bacteria, times e. It gave us k, which is 728 10,000ths, just thousandths, and then times t, and we're trying to solve for t, okay? So we need to get this e by itself. We're going to divide both sides by 10. So we end up getting 67 5/10 equals e to the power of 728 thousandths times t. So then we're going to use the property of equality here. So we've got natural log of 67.5 is equal to natural log of e to the power of 728 times t. So then we're going to use the inverse property. So then natural log of 67.5 is equal to 728 thousandths t. And then we're going to isolate t. So we're going to divide both sides by 728 thousandths. So you can do that in your calculator. Natural log 67.5 divided by 728 thousandths. End up getting 5.7859 equals t, which is about 5.8 days. Okay, when you round this off. Okay, all right. Next, this is another additional practice problem. So you will have one very similar to this on the test. It says to solve each equation or inequality. So here we're given this in logarithmic form. So we can rewrite this in exponential form. Remember, if you have log base b of x, that equals y. And then exponential form is b to the power of y equals x, okay? So this is your b value, this is x, and then this is going to be y. So we're going to write it in exponential form. So b is equal to 4, y is equal to 3 over 2, and then x is equal to x. So I can rewrite 4, this is the perfect square, as 2 squared to the power of 3 over 2, and then 2 times 3 over 2 is equal to 6 over 2, which is 3. So this becomes 2 to the power of 3 equals x, and 2 to the power of 3, 2 times 2 is 4, times 2 is 8. So this ends up being 8 is equal to x, okay? And then the last problem says to write 10 squared equals 100 in logarithmic form. So this is in exponential form already, where this is b to the power of y equals x. We're going to rewrite it in logarithmic form. So I'll write it over here. So log base b of x is equal to y. So we have log, our base, the b value is 10. Our x value is 100, and then our y value is the exponent, which is 2, okay? And that is in logarithmic form. That's all you have to do there, okay? All right, so thank you so much for watching this review for the Chapter 7 test. If you went through this review and you still have some questions, please stop by my office hours or email me, and I'd be happy to answer any questions that you have. Remember, I am here to help any way that I can, and please reach out. I don't know if you're struggling if you don't reach out, okay? All right, so I hope you have a great day and good luck on your test.